Okay, in this video we're going to look at how to find the area of a regular polygon. And we're going to start out by talking about some definitions, some particular parts of regular polygons. So the first thing is the center of a regular polygon is a point equidistant from each vertex. Equidistant just means the same distance from each vertex, and you can see here the center is already marked on this regular polygon. It's a pentagon. It's the same distance from each of the vertices, that's the corner points. The radius of a regular polygon is a line segment drawn from the center to a vertex of a regular polygon. So for example, this would be a radius. And notice I have a bunch of different radiuses. In fact, in particular on a pentagon, I have a total of 5 radiuses, since I can draw a radius from the center to this vertex, this vertex, this vertex, and so on. The central angle of a regular polygon, that's an angle formed by 2 radii drawn to consecutive vertices. So for example, here's a radius drawn to this vertex, here's a radius drawn to the next vertex, consecutive vertices. So this angle right here is what we call a central angle. So this angle, that's the central angle of the regular pentagon. Now, one thing to notice about the central angle, just like I have multiple radii that I could draw from the center of my pentagon to each of the different vertices, I also have multiple central angles. So here's one central angle. I also could have a central angle right here, and I could have another central angle right here. In fact, notice if I drew all of them, I've got a total of 1, 2, 3, 4, 5 central angles, and hopefully it's not too hard to see if I were to add up all of my central angles here. I've got 1, 2, 3, 4, 5. Hopefully it's not too hard to see that if I were to add up all of my central angles, then the sum of all of them, central angles, the sum of all of my central angles would be equal to 360 degrees. If I start here and I go all the way through all my central angles and get back here, that's 360 degrees. That's going to be a very handy property to know about any regular polygon. If you add up all of the central angles in any regular polygon, it's always equal to 360 degrees. We're going to come back to that in just a minute. Finally, the last thing to note about regular polygons is this thing called the apothem. That's A-P-O-T-H-E-M. And the apothem is just a segment drawn from the center of a regular polygon and perpendicular to a side. So on this regular polygon here, my regular pentagon, if I were to draw a segment from the center of my polygon perpendicular to, let's say perpendicular to this side right here, that would be an apothem. Now, in just a minute we're going to look at an example. We're going to find the area of a regular polygon. In fact, we're going to find the area of a pentagon. Notice that this pentagon, I've essentially divided it up into, right here I've got a triangle, and notice that this triangle is exactly identical to this triangle, which is identical to this triangle. That is, I've got a total of 1, 2, 3, 4, 5 triangles, and they're all congruent. I know they're congruent because the 3 sides of the triangle are made up of a side of the pentagon, and since it's a regular pentagon, all of these sides here are the same. Not only that, but all of the radii are also exactly the same, because the distance is the distance from the center to a vertex. Those distances are all the same. All those radii are the same. So what I have is essentially a bunch of congruent triangles, and I know they're congruent by the side, side, side postulate. This side is congruent to this side is congruent to this side is congruent to this side. I've got 5 congruent triangles. So what that means is if I can find the area of just one of these triangles, if I take that area and then multiply it times 5, because in this case I have 5 triangles in my pentagon, I'll have the area of the whole pentagon. So let's take a look at how that's going to work. Example number 1, it says find the area of a regular pentagon with a perimeter of 40 centimeters. So the first thing I want to do is I want to draw and label my figure. Well, in this case, the figure's already drawn for me. It says I have a perimeter. It has a perimeter of 40 centimeters. Well, if the perimeter is 40 centimeters and I have 5 sides and those 5 sides are all congruent, and I know they're congruent because it's a regular polygon, a regular pentagon, then I know the length of any one side of my pentagon must be 40 divided by 5, which is 8. So 8 centimeters is the length of any of these sides. So they're all 8 centimeters. All right. 2, on every type of regular polygon, when you're trying to find the area of a regular polygon, one of the things that you're always going to want to do is you want to find the central angle. And remember, we noted before how if we add up all of the central angles, in this case I have, here's the central angle right here. But remember, if I add up all of the central angles for this pentagon, it's going to be equal to 360 degrees. Well, since I have a total of 1, 2, 3, 4, 5 central angles, then if I want to find the measure of one central angle, I just take the total of all of them, which is 360 degrees, and divide that by the number of central angles I have, which is, in this case, 5, because I have a pentagon. So 360 divided by 5 turns out to be 72 degrees. Now I know the measure of this angle right here is 72 degrees. Next thing I want to do is I want to find the height of the triangle. And I'm talking about this triangle right here. Remember, I'm going to try to find the area of this triangle. Then once I find it, I'm going to multiply it times 1, 2, 3, 4, 5, because I have a total of 5 triangles. Well, the height of this triangle is also the apothem of the regular pentagon. And this height, notice when I draw my altitude or my height in this triangle, I divide these two triangles here into two congruent triangles. And that also means that this angle right here, which I just found is equal to 72 degrees, that angle, I have just bisected that angle. So this angle right here is 36 degrees. This one is also 36 degrees. Since I have an altitude right here, I've got a right angle, which means I have a right triangle. And let me break this triangle out down here. Here's this right triangle here with an angle of 36 degrees right here. Also, since I know the length of this side is 8 centimeters, and since these two triangles here are congruent, I know that this distance here must be 4 centimeters. Well, what I would like to know is what's the value of this distance right here. If I call that, let me call that h for my height, the height of this triangle. If I know this distance here, then I can find out the area of that triangle. Then I can multiply it times 5 and get the area of the pentagon. Well, I have a way to find this value here, h, by using this angle and using what I know about my trig ratios. Notice that for this angle, I'm given the opposite side, the side opposite that angle. I'm looking for its adjacent side. Well, that is the definition of tangent, opposite over adjacent. So if I just fill in the information that I have here, tangent of 36 degrees equals opposite is 4, adjacent is h, that's what I'm looking for. And now I just need to do a little bit of algebra. I take my calculator and I find tangent of 36. Tangent of 36 is 0.7265 equals 4 over h. If I put that over 1, now I've got a proportion that I can solve. So 1 times 4 is 4. 4 equals 0.7265 times h. I divide both sides by 0.7265. And I get h equals 4 divided by 0.7265 equals approximately 5.51. So now I have the height of my triangle. Well, now that I have my height, I can calculate the area of this triangle. The area of this triangle is, area of the triangle, 1/2 base times height. My base is 8. My height, I just found that, is 5.51. And if I multiply all that, 0.5 times 8 times 5.51 equals 22.04. That's the area of one of these triangles. Well, notice I have a total of 1, 2, 3, 4, 5 triangles. So if I take this and multiply it times 5, I'll have the area of my regular pentagon. 5 times 22.04, and 5 times 22.04 is 110.2, and that's going to be square centimeters. And I just found the area of my regular pentagon. Now you've got some other examples in your notes, and I want you to try these on your own, and we will take a look at these in class tomorrow.